Good morning, students. Now we will solve simply supported beam problem. Okay. So Young's modulus is given and Poisson's ratio is given. Now if you see, this is your simply supported beam, which is fixed on left side also and it is fixed on the right side also. And in between there is a point load of 20 Newton. And left side it is a hinged support and on the right side it is roller support. So you have to first solve this by analytical method. So for that you have to first find the reactions and then you should find the shear force and bending moment. Then draw the shear force and bending moment diagram and you have to draw the table. So in table we got shear force as maximum 10 and minimum value as 10. And bending moment we got maximum value of 2000 and minimum of 0. So let us solve this in ANSYS now. Okay, this is a very simple problem. Let's solve. Go to ANSYS, go to file, clear start new, do not read file, okay, yes, go to preferences, structural, okay, preprocessor, element type, add, edit, delete, add. So this is simply supported beam. This is also a beam only. So what you have to do, you should select beam only. If it was a bar, then you should select link and put this bar one. But this is a beam, so you should select beam to node 188. Say OK, then close. Now directly go to material properties. Here also you should not select use real constant option. Directly go to material properties, material model, structural, linear, elastic, isotropic. Substitute the value of Young's modulus and Poisson's ratio. 2E5, Poisson's ratio is 0.3. Say OK, close. Then go to section, beam, common section. So what is the section? It is 40 by 40. Put here 40 by 40. Then say OK. Now go to modeling, go to create. So we have to create 3 points A, B, and C, and in between we have to create the line. So it's a beam problem, so we have to give again key points. We have to see as first point 0, line, second point it is at a distance of 200 from starting. Put it here 200. Say apply. And third point it is at a distance of 400. This point C is at a distance of 400 from starting. So apply here 400 and say OK. So in between हम क्या करना है अभी? We have to apply the lines. We have to create the lines. इसको minimize करो. Go to lines. In lines, straight line. Select 1 and 2, then 2 and 3. Then say OK. Minimize this, then minimize this. Then go to meshing, mesh tool, line set. Select this both the lines. Say OK. And here you put number of element division 200. OK. Now again go to mesh. Now you say mesh. Select the two lines and say OK. It is meshed now. Now what you have to do? Directly go to solution. What you have to do? This side you have to fix and this side you have to fix. In between you have to apply the point load. Okay. So go to define load, apply structural, displacement on key points. Select this and say OK. Now it is a simply supported beam and that too this side it is a hinged support. So for that you should not select all degrees of freedom. You should select UX, UY, UZ, RX and you have to select ry. Should not select rz. Okay, this much you have to select and you should say okay. Now what you have to do, again you click on displacement on key points, select this last point, say okay. Now this side it is a roller support. For that what you have to do, you have to select only, you have to select only UI. Okay, then say okay. So this is the roller support. So on left side you should select UX, UI, UZ, RX and RY. And on the right side you should select UY. Okay. Then in between there is a point load. So for that you have to go to force on key points. Now we need point where it is. Okay. So this is your point. So select that point. Say okay. Direction is FY. What is the value of force? It is 20. So you substitute here minus 20 and say okay. So this is the force. Now go to solve. Say current LS and okay. The solution is done. Close this. Close this. Now go to general post processor. In general post processor, you should directly go to element table, define table, add, come down by sequence, LS, LS1, apply, and come down by sequence, SNSIC3. Again, same, you have to just find out shear force and bending moment here. So by sequence, SNSIC, apply, come down by sequence, SNSIC, 6, apply, come down, SNSIC, 90. Say okay. So 3, 16, 6, 19. So this extra UX something has come. Let us delete that. So this is our value. So now what you have to do, directly go to plot result, contour plot, line element result. Then on the top you select 3 and here you select 16. Say okay. So this is your bending movement. Okay. So this value you have to write. So minimum is 5, maximum is 1995. So that value you have to write it in the table. Minimum is how much? 5. So how much you had got? 0. So that you have to write. Maximum is 2000. How much you got maximum? 1995. So it is exactly nearby answer. So that value you have to write. Then again click on line element result. Now you select 6 and bottom you should select 19. Say okay. So this is your shear force. Minimum is 10, maximum is also 10. So you have to put here maximum 10, minimum is minus 10. So these are your values. So this completes your fourth problem. Thank you.